In this video, you will learn how to identify the 5 different types of reactions. So the first is synthesis. Synthesis is where you combine 2 elements to make one compound. So the reaction framework is going to look like this. It will be A plus B. Those are 2 different elements that combine to make a single compound. So stick the 2 elements together. Decomposition is just the opposite of that. So this is where you take one reactant and break it into 2 products. So in this reaction framework, we have AB, that's a compound that has 2 elements in it, and we break it down into its 2 elements, A plus B. Next is combustion. So this is where you have oxygen. Oxygen is diatomic, so we see it as O2. And it reacts with a compound. This compound will always be what we call a hydrocarbon. So it's something with carbon and hydrogen in the formula. And then we always create the same 2 products, H2O and CO2. With single replacement, this is where we have a single element that replaces another element in that compound. And so here we have the reaction framework. We have A, that's our single element, plus BC, this is our compound. And what happens is A and B swap places. So we make a new compound, AC plus B. And then double replacement, our last one, is where you have elements in each compound swap places. So we have AB plus CD, and then we create a new compound between A and D, between those elements, and another new compound between element C and B. So knowing these reaction frameworks is going to help us to identify the 5 different types of reactions. So this slide is just a summary of the previous 5 slides that we looked at. When we identify the 5 types of reactions, we will follow 3 steps in order to do this. So the first step is check to see if the reaction has only these 3 elements, C, H, and O. If it has only these 3 elements, then the reaction is combustion. So if it's not combustion, we move on to step number 2. With step number 2, you need to assign each element or polyatomic ion to a letter. So A, B, C, and D. And then third step, use the reaction format to identify or determine the type of reaction. So let's look at 5 different examples of this. So in this first example, we have Mg plus O2 that makes MgO. I'm going to assign each element to a letter. I guess first step, we identified it wasn't combustion. It does not contain only the elements C, H, and O. So element A plus element B, and this makes a new compound. Magnesium, Mg is A, and O is B, element B. So we can go back to our reaction frameworks, and we see that this matches synthesis. A plus B makes AB. In this next example, we have NaOH plus FeCl2. So I'm going to assign Na to letter A. OH, that's the polyatomic ion hydroxide, so that's B. We're going to keep that together. Element C is Fe, and then Cl is element D. We can see that on our product side, we have A and D that combine to make NaCl. And then we have element C, that was iron, combined with the OH, that was element B, to make another new compound. So this matches double replacement. We can see the reaction framework is AB plus CD, and that makes 2 new compounds. In our next example, our first step is to check to see if it's combustion. It is because it contains C, H, and O. It doesn't contain any other elements. So that means it's automatically combustion. In our next reaction, we have Mg. So we know it's not combustion. We're going to assign each element to a letter. So Mg is A, Na is B, and Cl is C. And what we see here is element B is now all by itself, plus we have element A, that was magnesium, combining with element C, which was chlorine. So go back to our reference slide, and we can see that this will match the single replacement reaction. So our last example, we know it's not combustion, it has lithium in it. So we're going to define or assign each element to a letter. Lithium is A, oxygen will be B, and then we can see it breaks into two elements. So we'll have A plus B. So this matches the reaction framework for decomposition, where you start out with one compound and you break it into two elements. One other skill that you may need to know is how to identify the reaction type just from the reactant. So we're also going to go through some examples of this. So let's say you're just given the reactants and you're asked to predict the products, but you don't know what type of reaction it is. You do need to know the type of reaction in order to be able to predict the products. So we're going to use the same format or same steps that we used before. So I'm going to start just by giving each element a letter. So H2 plus O2, that's A plus B. So the only reaction framework that matches that is synthesis. So this first one is a synthesis reaction. Our second example here, we have Zn and Br, those are two elements. So I'm going to assign each to a letter, plus F2, so that's element C. So looking at our reaction framework, this is a single replacement reaction. We have A plus BC, or AB plus C. So this is single replacement. In this next example, we have two elements that are combined together. So we have one compound. The only type of reaction where you just start out with one reactant is decomposition. So this third example is decomposition. In this next example, we have only the elements C, H, and O. So that is automatically combustion. And then in our last example, we have a bunch of polyatomic ions. Each one will assign to a letter. So you can see that we have two compounds here. So two compounds, AB plus CD, that will be a double replacement reaction. That's the only type of reaction where you have two compounds.